7.5 is on matrices, and you've kind of dealt with matrices already a little bit in 7.2 especially. I think if you watched some of my videos, you saw that I did it with matrices. I didn't specify what they were, but I was just setting them up. That's what we're going to talk more about in this section. So a matrix is just a collection of numbers that has columns and rows. So let's talk about the order of a matrix first. The order of a matrix is going to be done by, the order is kind of like the size, is row by columns. So if you see, let's say the order of a matrix to be 3 by 4, that means it has 3 rows and 4 columns. Types of matrices. There's several types of matrices that you're going to see, especially the square matrix. We will definitely talk about this one. A square matrix has the same amount of rows and columns. So for example, that's a square matrix because it's a 2 by 2. This one's a square matrix because it's a 3 by 3 and you can go on forever. A row matrix is just one row. So it just has one row and it can have as many columns as you need it. A column matrix has only one column. And as many numbers as you want it, has many rows. So let's go to some operations with matrices. Let's talk about addition and subtraction. When you're trying to add or subtract two matrices, let's say, let's call A and then B. If you want to add them, you're just going to add the corresponding terms. Like the -2 goes with the 8. So when I add them, I get 6 and I put it there. This one goes with the 1. So 3 plus 1, 4, and I put it there. This one goes with this one. So that's 5, and 1 plus 4 is 5. Now, in order for this to work, the matrices have to be the same size. If they're not the same size, you're going to say not possible. See, if they're not the same size, then it's not possible to do this because we're matching the corresponding elements. So if you're subtracting, you got to be a little bit more careful because of that extra minus. But it would be -2 minus -8. So -2 minus 8. 3 minus 1. 0 minus 5. Wait, I'm in the wrong spot. 3 minus 1. 0 minus 5. 1 minus 4. So I end up with -10. 2. So basically you do have an extra minus there that you have to worry about when you're doing the subtraction, but it's the same idea. Now the one that can be harder is multiplication. In order to multiply two matrices, you have to get their order, both of the matrices, and this has to be the same so you can multiply them. And then if it is, then you're going to look at the size of the answer is going to be like that. So the same to multiply. And what I have here in the bottom, this is the size of the answer. So let's take A to be Let's say this one. And then B to be this one. So if they ask you to find A and B, for example, we're going to get the order. The order of this one is 2 rows by 3 columns. And this one is 3 rows by 2 columns. So the order of A is 2 by 3. And the order of B is 3 by 2. You see that this here in the middle are the same? That means we can multiply them. And now, to set it up, the way you're going to multiply is the following way. You're going to look at the last number. See how it's a 2? So the 2 tells you how many times to multiply the first matrix. So in this case, the first matrix is A. So I'm going to grab A and I'm going to write it like this. I'm going to put parentheses next to each number. If the number is positive like the 2, I put a plus. If the number is negative, I put a minus. So like for the 0, I'm just going to put plus. And then for the 5. Now, because there's a 2 here at the bottom, at the end, I'm going to write the same thing twice. So what I did was I grabbed the first matrix, which in this case was this one, letter A, and I put the matrix with parentheses next to each number. The last number is a 2, so that's why I did it twice. Okay, now that I've done that, I'm going to go to the other matrix and grab the columns, and then the columns are going to go here. So let's say the first column, I'm going to put 5, -4, and 2, and then I'm going to put it down here. And then the next column is going to go on the next matrix. So that's going to be -1, 0, 3. -1, 0, 3. And then you just do the arithmetic for it, and you get the answer. So when you get all of that, you get -7, 30, 10, and 11. Now let's say I want to do BA. B is 3 by 2. You see the order there. And A is 2 by 3. Again, look at the middle. It's the same. So that means we can actually multiply these. And I'm going to grab the first matrix. So in this problem, the first matrix is actually B. So I'm going to grab B and do what I did for A. So I'm going to do 5, parentheses. Since there's a -1, I'm going to put -1 like this. And then the 4. So I'm putting parentheses after each number like this. This is 1. And since I have a 3 at the end, I'm going to do this 3 times. See? This is twice. And one more time because I'm supposed to do it 3 times. Okay. And then I'm going to take A, which is the second matrix, and I'm going to get the column. So like this column is going to go here. -1, 4. And I just carry it down. And then this column is going to go on the second matrix, 2, 0. And then finally, this last one is going to go on the last one. And then we just compute the arithmetic here. And you get -9, 4, 10. 10, -8. Now your answer must be the order of this last one. So it should be 3 by 3. See, which it is. And then if you look at this one, my answer should be a 2 by 2, which it is. Multiplication can be the most difficult one here to remember how to do. Yeah, so that's what I have for this section. But if you have any questions on anything else that you see here, these examples are similar to that. Let me see. Yeah, similar to what we saw, what I just did. So these are good practice. I know I don't have the answers for them here. So maybe I should work on some of these with you because I'm looking at them and some of them I don't think I put them in the worked out notes. So let's just work on some of them here for you so that you have the answers because you're not going to have them for you. So never mind, we're not leaving yet. So like the order of the matrix. The order of the matrix is the size. So on here, you're going to put rows, the number of rows. And on this one is the number of columns. So how many rows? 2. How many columns? 1, 2, 3, 4, 5, 6, 7, 8. So that's how you write that. Now the addition, you're just adding the matching terms like the -3 with the 4, the 8 with the -10. So you see you're adding just the corresponding terms. And that's how you add. You just add like the 3 with the 4, the 8 with the -10, and so on and so forth. When you have numbers in front of the matrix, you actually multiply the matrix by that number. So like here, all of the e's would get multiplied by a -2. So now all of the g's get multiplied by a 4. Like that. And now we just add the corresponding terms. So like the -16 goes with the 28. The 12 with the 4. The 20 with the -32. The 10 with the 24. The 0 with the 16. So you're matching the corresponding terms and adding them up. So that's how that works. And then on this one, you would do the same idea, except you would be subtracting. The augmented matrix, this is an augmented matrix, write it as a system. So basically the first column has the x's, the y's, the z's, equals, and then the numbers. So to write it as a system, you are basically just copying the numbers. See? Into the system of equations. And then the other one is where they give you, this is to multiply. And then this one, they give you them, and we want to write the augmented matrix. You first check that everything's in order, see all the x's, all the y's, all the z's, and then the equal, and then the numbers. And if that's the case, then you're just going to copy the coefficients next to the numbers. You see? And then once you have that done, then that's the augmented matrix. Now, if you have any other questions on anything else on the section that I didn't cover or that you saw here and you still have questions on, please let me know. And I can make some extra videos or just send you an explanation to your specific problem.